Work it, make it, do it, make sense.
Good morning, everyone. Thank you very much for coming along to the Microsoft presentation. I know it's a Java conference, so coming along to a Microsoft presentation, thank you very much. I know it's taking the time. My name is Justin Davies. I'm the open source technical lead at Microsoft, so looking after Linux, Java on Linux, Java on Windows, and looking after our ISVs as well, so the likes of Docker, Chef, and Canonical as well, who are going to be coming on stage with me shortly. I think historically people don't associate anything non-Microsoft with Microsoft, especially even when it comes to the cloud as well. And we're here really to be able to kind of dispel that myth. Satya Nadella, our CEO, 2014 really internally at Microsoft said that he wants everyone to work with openness in mind. So, developing in the open so that other development teams can see what other development teams are doing, and everyone to be able to work under the ethos of open source being the driving force behind what we do internally at the company. And okay, that's not world-changing or dramatic in terms of that. It's just changing the internal way that we work at the company. It wasn't until later then that Satya got up on stage, and we have this slide here, Microsoft loves Linux. I'm not going to bang on about Linux and kind of what we're doing with regards to it, but really what I want to highlight is the fact that I think a lot of people historically wouldn't have assumed that this type of messaging would have come from Microsoft. And we want to make sure that as a company, anything can work within our cloud. It doesn't have to be Microsoft. It doesn't have to be SQL Server. We want to make sure that if you have a workload to be able to come to Azure as a cloud provider, it will work, and it will work in the best way possible. And the way that Microsoft does this is that we initially enabled the platform itself to be able to run non-Microsoft products. So initially the first one being Linux. We contributed a huge amount to the Linux kernel to be able to make sure that the operating system ran as well as possible under Hyper-V, which is our hypervisor. We obviously work very closely with the likes of Docker as well in terms of making sure that Azure Container Service, which is essentially an infrastructure orchestration layer within Azure to be able to run Docker Swarm, Kubernetes, and DCOS or Mesosphere, and be totally automated and essentially looked after for you. You don't have to worry about the underlying infrastructure. A couple of steps further is that we've actually taken open source projects that we consider best in breed to be able to provide good, solid functionality to our customers, and actually provided a service around those as well. So the likes of Redis, key value store, and distributed caching system, as I said, Docker being part of Azure Container Service as well, and the likes of our kind of big data as a service, HD Insights, is actually based on one of the largest providers, which I've just forgotten actually. HD Insights. Help me out. It'll come to me, I'll say it in a second. I'll come back to that in a second. The other thing that we've done as well is that we've actually open sourced our own pieces of software, which were considered to be core company intellectual property. So the likes of PowerShell, the .NET Foundation as well, we've open sourced that and we developed that in the open. So that allows our customers to be able to be involved in the development of those pieces of software, and allows them to be able to see what we're doing in terms of fixing bugs and moving the software forward. And then we also contribute back to open source software, so the likes of Linux, Docker as well, but then contributing back to the likes of Python as a programming language and taking the learnings that we've had from running a hyperscale cloud environment globally and feeding that back into open source projects. So finally, before I hand over to Canonical to be able to go through their demonstration, Azure is an open cloud. We provide a kind of a home for not just the operating systems, but also the likes of big data, Cloudera, MySQL, PostgreSQL being hosted and being managed within Azure for you. All of these people and all of the logos that you see on here, we have relationships with them, and we have both strategic, so kind of commercial relationships with them, but also engineering relationships as well. Our engineering teams and their engineering teams working together to be able to make sure that, again, those pieces of software are best in breed running on Azure as a platform. So that's kind of the Microsoft story, where we are really in terms of Azure and it being open. It's not just Microsoft, and I think the demonstration in terms of our partners being here to be able to show what they're doing with Azure and with Microsoft is testament to that as well. So with that in mind, I'll hand over to Nicholas from Canonical to be able to go through Juju. Thank you, mate.
Thanks, Justin. Hi, everyone. I'm Nicholas Dimotakis. I'm from Canonical. So in case you haven't heard of us, we are Ubuntu. We are the company behind Ubuntu. So I'm sure you're aware that Ubuntu is effectively the developer's choice for the desktop, and I'm pretty sure many of you might have already used and are using Ubuntu. But one thing that maybe you're not as aware is that Ubuntu is the developer choice for the cloud. In fact, all the big companies, the big successes right now that are using cloud technologies to operate, you can see all there, are all running on Ubuntu. Everything that is scale out and cloud effectively runs on Ubuntu. 75% is a magic number that we tend to mention in general. So effectively 75%, apologies, of Azure's Linux. So of course Azure runs a lot of Windows virtual machines, but anything that's Linux, about 75% of it is Ubuntu. 75% of all the open source projects there are also Ubuntu. Same thing for the ARM templates. HT Insights, in fact, runs on Ubuntu. The default Docker images are, again, Ubuntu. If you get Kubernetes on Azure, the default Kubernetes, again, that runs on Ubuntu. And a number of other key services, effectively. So Ubuntu has been the platform of choice for developers. So this is the reason why, as development started moving to the cloud, Ubuntu came with it. And that's why it became, again, the platform of choice. Just a little bit about how we see the world at Canonical. So we see the world on two sides. So one is the elastic hybrid cloud. So effectively is a number of machines in the private and public cloud. It's the ability to scale out either as your private cloud or scale out elastically into the public cloud as well. It gives you, you need to have the capability effectively to have machines everywhere, right? Have running machines and services everywhere, scale as you need, have the high availability exactly as you need it, and be flexible. So this is one side of the story where effectively you stop caring about individual machines, you care about your applications. If a machine dies in the cloud on Azure, you guys don't care. You're still going to get your service. You're never going to experience that the machine died, right? So cloud is built in this way. On the other side, though, when we talk about the transactional edge, we're talking about individual devices, robots, drones, cars, self-driving cars. So all of these devices effectively are on the edge. They have importance on them by themselves. So they're not as redundant as you have within a data center, a specific machine. If a drone dies, this is a problem, right? If a base station that provides a 4G service somewhere in a telephone pole or somewhere in an electricity pole dies, somebody needs to roll a truck and go and replace that. So the importance of the transactional edge is quite different from a device perspective than what is in the elastic cloud. Ubuntu effectively plays on both sides of the spectrum and deals with both sides of the spectrum quite differently. Over here, we build tools such as Maz and Juju to handle machines at a very large scale and to provide that elasticity at a very large scale. On the other side, we have Ubuntu, which works with snaps, and snaps enable you to secure your device, to provide updates to it without endangering a corrupt device, which again will require you to roll in the truck or to do a complete firmware upgrade. So we're always thinking of what is the importance of each type of device on one side or the other. One thing that I'm sure you're aware of is that software is becoming cheaper and cheaper to the level of being free, right? This is the whole point of open source. So license costs have been going down. I'm pretty sure you've experienced this with Microsoft as well, and with pretty much everything else that you use as developers. You tend not to buy licenses anymore. However, what has increased is the cost of operations quite significantly. Why? Because you have a very large number of new pieces of software that all need to work together to provide the service that you need. In the old world, you bought a license from one vendor, you had your whole piece of software, everything was working, you had one maintenance contract, you had some experts on it, and that was fine. Right now, when you go to anything that requires 5, 6, 7 pieces of open source software, you need to have the people that have the expertise to operate that software. And I'm not just talking about using the software, I'm actually talking about operating it. And so the big challenge is, how do I operate efficiently and economically? And this is what Canonical has come in to try and solve. So let's talk about deploying and operating. How can I deploy Swarm, for example, or Zeppelin, or Hadoop, or Kubernetes? And how can I operate that in Azure Cloud, for example, in minutes, or in my local machine because I want to develop something very quickly? Well, it needs to be done in exactly the same way, right? So effectively, you need to have the ability to deploy any bundle of open source software or even licensed software in an easy way, and you need to be able to operate it in exactly the same easy way. And when I say operate, I mean you need to be able to scale it out. I'm running Swarm, and I'm running 3 workers of Swarm within my bundle, and I need to increase that to 5 because my workloads have really increased. Well, I need to do that in 2 minutes. I need to just click on something and say, allow me to expand my Swarm into 5. I need to be able to upgrade it. Right now, we don't have the capability to take things down anymore. Things are running in production, and we need to be able to do upgrades live in production. And I need to have that capability. But I don't want to have to hire the people to have all this knowledge, this operational knowledge. I don't care about that. I want to use the software. I don't want to spend a lot of money operating it. So effectively, what Canonical has come up with is Juju. Juju is an application modeling tool which focuses on economically and effectively operating big software, as we call it. Each circle that you see there is one piece of software that you can bring in from our store. Each circle is called a charm. A charm effectively is the operations code and deployment code for each piece of software. So if you see, for example, there at the top over here, we have Docker Swarm, and we have other pieces of software like Consul, we have FileBeat, TopBeat, and of course we have Kibana for monitoring purposes. And I want to be able to deploy that without having to think, oh, I need to bring all these different pieces, I need to write some sort of script to bring them in together. No, I want that code to exist somewhere. I want it to be able to deploy these things very, very easily, and then I want to be able to operate them very easily. Let me show you, apologies. Let me show you what I mean. There it is. So here is Juju. Sorry. Oh, how do I? Ah, yes. Sorry. Okay. Is that okay? Perfect. So here is a model that I started to spin up a little bit earlier. This is the canvas. I basically went in. I created a new model in Juju, and I said I would like to install Swarm. So I search in the store. I find either the individual charm for Swarm, or I find the whole bundle, which includes a number of other pieces of software. I add it to the model, and as you can see now, it's starting to bring from the Juju store the different pieces that make up my bundle. So let's say I want to deploy that to Azure. So I would like to deploy the changes. You can do this, by the way, with CLI. It's Juju runs completely on CLI. I click on Microsoft Azure. Let's say I choose the region West Europe. Let me put the SSH key here. That is Justin's SSH key, if you can remember it. As if that makes any difference. Okay. It basically says the machines to be deployed are 9, so I need 9 machines to deploy this bundle. And then I click deploy. Sorry. I need to change the model because I already did one of those. Apologies. Let's just call this Docker Swarm. Okay. I click deploy. And then if I go over here, you can see that it's starting the deployment, and you can see exactly the status of each one of the pieces of software. So if I refresh now, there should be a new resource group. There it is, Juju Docker Swarm. So as you can see, what's happening is automatically Juju is requesting machines from Azure. And it's saying, I would like 9 machines. I would like those machines to be of X, Y, Z specification. And then I would like you to deploy, for example, Ubuntu on those machines. And then I would like you to download the software and install that, create the relations between those pieces of software, and then expose it so I can use it. And exactly this is what's happening. So effectively, you end up with your complete bundle that runs Docker Swarm. And I'm now going to pass it over to Docker, who will talk a little bit more about Docker Swarm.
Thanks very much. Okay. All right, am I coming through? All right, hi everyone. My name's Steve Thwaites, and I work in London for Docker. If you're looking for sort of one slide for what Docker's been up to, or what we're trying to do, it's really here. We're trying to get all the tooling that spans across development and operations across multiple different platforms for working with containers. So we're not really opinionated about where you want to run your workload, or what workloads you want to run on the platform, but all of the tooling that spans all of that. Hopefully everyone is kind of had the 101 talk on Docker before I proceed, so cool. So just a few things that you might be unaware of, some of the more recent stuff that's happened in Docker. Docker's obviously started life as about 4 years ago now as just as a container engine, and obviously over time tons of new technology has been piled in there, things that handle orchestration, networking, service discovery, storage, all that kind of things as well. And now we have the Moby project. This was recently announced at DockerCon, and this is actually an upstream of Docker now that has all of the components that make Docker what it is, separated into separate projects, which are more generic and that can be assembled into other as a component of other platforms. So this is kind of given a lot of people what they were looking for, because Docker got quite big over time. And it's also now part of a set of upstreams. So I guess an analogy would be sort of Fedora into RHEL, for example. Another one is around containerd. So this is the container supervisor, which runs and looks after every container that's running. And that's been recently given over to the CNCF, the Cloud Native Computing Foundation, also the sort of custodians of the Kubernetes project. And alongside all of that, we're now distributing our assembly of those components, Docker, as CE and EE. So CE is free for developers and for developer sort of platforms, free operating systems, and then EE, Enterprise Edition, is for production and sort of production-grade OSs. We're always working to broaden OS and platform support. So it used to be just Linux x86, but now, of course, Windows is coming into play, ARM devices, and of course working with integrations on different clouds as well. And this is really where some of our work with Microsoft has been come to fruition. We've had an engineering relationship with Microsoft since 2014, and that's now sort of yielding results all across the toolchain. So the mantra at Docker is build, ship, run. So I figured in the time that I've got, I might just go through these things in turn. So on the build side, for developers, there is Docker CE for your development workstation. So if you're running Windows 10 Pro, or if you're running Mac OS 10, you can just download Docker CE, and it's just a very, very nice integrated experience. So some of those upstream projects like HyperKit and VPNKit are put to use here to expose the hypervisor framework in Mac OS 10, and we use, of course, Hyper-V built into Windows 10 to give a embedded Linux virtual machine. So you could get to work for creating Linux containers, but in a very kind of seamless manner. And you might be able to see at the top there, we're actually switching between working with Linux containers and Windows containers on the Windows edition, because we also have the ability to run the Docker engine now on Windows. Huge plugin support across the whole sort of, much of the tool chain. So plugins, of course, for your IDEs, including Visual Studio and VS Code. The build tools like Maven and Gradle all have very strong and mature Docker support now. If you're working with Docker Machine for creating development machines as well, the Azure plugin there, which allows you to go and spin up new engines on demand. And of course, Microsoft is now contributing images to the public Docker registries. So the Docker Hub and the Docker Store are examples of that, and that's where Microsoft are now publishing a lot of their sort of core technologies on which you can build your work. So that could be Windows Nano Server images to provide you that base image that's used as that base user space where you add all your software, but also their middleware as well, things like .NET, IIS, etc., ready just for you to add your own content and then immediately deploy. And that's those are just examples of some of the official middleware images that we have available. So lots of the projects have official images, if you like, from the projects themselves. So that would include like Tomcat, but also the Enterprise Java middleware as well from Oracle, IBM, and others now have official support now on the store. On the ship side, so new in Docker, if you're on the CE release, you can actually subscribe to a Edge channel. So there are stable and Edge channels available. Stable will come quarterly and will generally have all of the baked features, and Edge comes every month with whatever's coming out as new features for you to test. One of the new things there is now multi-stage builds in Docker, which is really nice. That means you can, instead of having to put all of your sort of build software into the actual final image, you can run your build process, and that will actually use a particular base image with the software you need to build your artifacts, and then continue that build with potentially another different base image that's used for deployment, which has long been asked for and is now finally here. Integrations, of course, with Jenkins, VSTS, Team Foundation Server, TeamCity, all of the CI tooling now have pretty strong Docker support as well. And on the registry side, registries being, of course, where we keep our Docker content and images, we have, of course, the public Docker Hub, which has now had something like 12 billion downloads now. We're having like 1 billion downloads every 5 weeks. It's crazy. And, of course, the Azure Container Registry, which is offered directly on Azure from Microsoft. For the enterprise as well, we have Docker Trusted Registry, and this can be deployed on-prem or up in Azure, if you like, which will give you a few extra kind of enterprisey features surrounding your registry. Things like access control, of course, so you can control who does what and who can do what within your repositories, but also features like image scanning, which will actually look inside your image. I can quickly show you some of that in a second. Image signing as well, so you can actually add a digital signatures to content that you can verify on deployment. And things like webhooks as well, so you can trap these events happening in the registry and then kick off your own automation. Yeah, so lots of the all of the open source APIs apply, of course, in Enterprise Edition. But these extra webhooks and things give you the ability to tie this and integrate this well into whatever your pipeline is. And of course, run. So on the run side, this is really where Azure becomes a target for us as a place to actually create infrastructure to run containers and then actually start our containers there. So from a user experience perspective, Docker's, it's very much its strong point is that it's actually very, very similar all the way across different platforms. You're effectively operating, when you're using your CLI, an API client, you're using the Docker client, you can point at something local when you're doing development, and you can just change where that's pointing and point to a server in your data center, or indeed servers out in the cloud. And so we can deploy a swarm, as has been done already, and that will give us a bunch of features that we're going to want to use in running containers. So now includes built-in orchestration in Swarm. This gives us, it's a very secure orchestration framework. It has load balancing and high availability features. So built in, you can just deploy multiple replicas of one component of your application, and they all, service discovery, DNS resolution, and load balancing is all kind of built into that, and that gives us the ability to handle rolling upgrades, which was often something of an achievement to actually hand crank and make happen yourself. But now it's just part of how this stuff works. Most recently as well, secrets management is now part of this as well, which is really nice. This means we can have someone deposit a secret in the swarm, and it's encrypted on disk, it's encrypted in flight on its way to deploying the workload. And then someone, I don't need to know what that secret is or have access to it. I can just reuse it in my specification. So I can say this application needs to be able to see, for example, a connection string or a database password, and it will be encrypted in flight, decrypted on the fly, and then exposed to the container so you can use it in your application. And Azure integration. So this is, there's loads of scope for this. Of course, we're building a container infrastructure, so there's lots of things we can reuse from Azure. So one example is when you're persisting storage outside of containers, you want to do that to some sort of disk that survives after the container is upgraded or is destroyed. And we can use the Azure storage plugin for that. So this trivializes, setting up external volumes for your containers. OMS, so we can actually gather, we have an OMS image for Docker as well, so we can actually run that on our engines and then collect all the data that's for what's happening on the engine itself and inside your containers, and actually send that straight out to Azure for your own analysis. Azure extensions for Docker, so if you want to just go pure infrastructure as a service and make this happen through that way, then you can actually use the extensions to set up Docker inside your containers, inside your instances. And then ARM templates. So if you know that what you want is going to be pretty generic, or if you want to set something very quickly for development, we do have ARM templates available that allows you just to settle this up and click. And there's an image there on the right which kind of shows some of that. We're making full use of VNets, the load balancing, etc. in Azure as well. And as of last year, the support for Windows Server was added in Docker. So that means it's no secret. In Linux, we've been reusing Linux kernel components. It's just a very nice interface for setting up all of the settings in a kernel for running a process in isolation. And we can do the same now in Windows. Part of what we've been doing through engineering with Microsoft is arriving at a set of analogs in the Windows kernel that allow us to present the same interface to users. So Docker pull, Docker run, Docker build, all look and feel the same, even though the implementation is underneath, and the result is the same. So we had that engine release happen around the time of Windows Server 2016 release at the end of last year, and now we're about to add Swarm as well to Windows. And so it'll be coming very soon. And the result will effectively be you can have a mixed mode swarm at that point. So you can have different components of your application running on different operating systems, and still using overlay networking and a unified experience across both platforms. So I expect that to be a big deal when that lands. Aha, right, a quick demo. Ooh, there we go, cool. Okay, fantastic. So I've deployed my Swarm into the cloud. I'm actually using EE here, just because you don't want to watch me type. I don't have much time. But the process is effectively the same. With EE, you have we develop API first, so everything we're doing here through the GUI, we're also able to do through the CLI as well. I'm actually using this example application. I'm posting links to all this stuff at the end as well. But this example application has multiple containers expressed as a compose file and a stack file. So Docker compose is a YAML expression of all of your containers deployed together on your development system, so that you can build and you can actually get a full multi-container application stood up together. And then we also have what's called a stack file, which is very similar, lots of shared syntax. But we're more concerned with the actual deployment onto a Swarm at this point. This gives us a few extra settings we can work with. So how many replicas of each service we're going to have, or if we're performing an update, what is the parallelism of that? Like, am I going to do one replica at a time, 15 seconds apart, and how do I handle failures, etc. These are all things that we're able to handle through this, and then use the Docker client. It's just the command docker stack deploy, and then passing this file. I've already done that here. So here in my... Everyone see this all right? A bit bigger? Too big. Yeah, probably too big. Yes, not that bad, is it? Okay. So I've got this voting app deployed here, and you can see it's actually composed of multiple services, all running together. Some of them I have multiple replicas and are being load balanced, and some are just single instances. So this was deployed using the stack deploy command. You can see here that we're using particular images at for each one of these. So basically, a service is one or more replicas of a particular image and their associated settings. And here I have this voting app. Okay, so you can see here we've got this voting app, cats versus dogs. So people can vote for cats or dogs. Anyone for cats or dogs? Cats, thank you. No, I'm going to take the first answer. Sorry, guys. So that looks like that's working, right? So the Redis cache is doing its job. Very nice. Cats win. Okay, but so that's one version of my app. I also have, I actually have deployed, but not logged into. Let's try that again, shall we? I told you didn't want to see me typing. There's my one. It's PLB. Oh, I need my URL for my DTR. Never mind, I'll have to come back into that. I have a registry, and my registry basically contains these images, but I don't have the URL up in the tab now. But basically, when those are all been built on my development machine, pushed to that registry, where they have been security scanned as well, so you can actually have a full report on whether or not, what your exposure to risk is in terms of these components were found inside your image. They might have certain CVEs, etc., and you can browse all of that. But really, what we're trying to do here is an in-place upgrade. So we're leveraging all the load balancing here. One thing that's really nice about deploying on Swarm on Azure is that we actually do hooks into the platform. It's not just a case of just having some instances and then deploying Docker as normal. We have some extra hooks in there. For example, when I start my containers and I'm publishing the service on a particular port number, in this case 5,000. I don't need to go into Azure and open up port numbers on load balancers or elsewhere. This is something which is happening seamlessly as we do our deployment. Really neat. So my voting app. Let's just take the... right then. So I want to do a vote. So it's currently using the tag before. I'm going to switch that out. Okay. Let's scroll over here. Come on. Thank you. So that's the SHA hash that for the image that we're using. I'm just going to refer to a different tag and choose after. I'm not going to right click. Let's do that one more time. Okay, and I'm going to commit that and save that. And that's kicking off that background orchestration process. If I wanted to just modify my stack file to refer to a different image or a specific tag or hash, I could redeploy using the CLI in exactly the same way. And it would have the same effect. A comparison would be made against the current setup and the desired one, and it would reconcile. So I do that for the voting, and also for this one. So we have the two different apps actually, they're written in different languages. This is all out up on GitHub. And it's performing this rolling upgrade for me. So in a few moments, that should be committed. And then so basically what's happening now is it's actually one by one taking these containers down and then restarting them in the other version. So it'll be pulling the others in the background. Okay, how are we looking? Coming up. Still updating. Still pulling. Okay, we should be in good shape. So now, let me do a refresh on this. Oh, get back there. Okay, so this is our new version. Can do votes between Java and .NET. Okay, that's actually been completed. So how shall I vote, guys? Good stuff. Okay, and that will update in just a second. But it just goes to show, you know, with the tooling, with the experience that you have. This will refresh in a second. It's a fix. It's a fix. There's someone behind the curtain. However, you get the idea. We're now in a new state. Okay. Well, that's my little demo. There's a bunch of links here as well that I will make sure this is available. But there's a bunch of things that you might want to see that are relevant to the other talks as well from today. One of them is, I really want to call out as well from this list, is image to Docker. This is something that we've been working on for a while. It's open source. It's out on GitHub. Go and check it out, because what it does effectively, it will inspect your existing virtual machine and then do some inspection of that, and on known workloads, basically suggest a Docker file to recreate that and provide your artifacts back to go and rerun that. So the one which is furthest ahead right now is the .NET one for Windows. So that will actually, it's a PowerShell script. It goes and looks at what roles and features you have installed, etc. Looks at your IIS and .NET configuration and goes and gets your artifacts and gives you back a folder full of all the things you need, or a suggestion to get you most of the way there. And the new one we now have as well on Linux will do the same for, I believe, Tomcat today as well on Linux as well. And there's links to sample applications and more. That's me. Thanks.
Hi, everyone. My name's Russell Seymour from Chef. I work on the partner team at Chef, primarily focused at the moment on working with Microsoft Azure. So thank you, Steve and Udi and Nicholas for the infrastructure. So what I'm going to talk about is Chef compliance. Can I just have a quick show of hands? Has everyone heard or used Chef? Yeah, and of those people, have you heard of or used compliance? Okay, so that's what I thought. What is Chef compliance? Well, Chef compliance is a policy-driven system that checks to see if your machines are in or out of compliance. The policies are written in spec, which is based on server spec, and this is an open source tool that allows policies to be run very easily. And you can create your own policies. There are lots of contributors to the policies. We contribute the CIS, which is the Center for Internet Security. They create policies. And what it allows you to do is run policies that could be governmental, so Sarbanes-Oxley in America or PCI here. You might have industry policies, so if you're in the retail, you need to make sure that your, for example, credit cards that are saved are securely encrypted. You might have internal company policies that, for example, you're only going to support TLS in your web server, or that you make sure that you're only supporting SSH version 2. And you could have design and development policies that you have within your architecture team. And you can do lots of other tests. For example, you can see if your Windows and Linux patches are at the right level. You can check that your SSH, as I said before, is correctly configured. As I say, there are lots of policies, but you can write your own. Now, what I've got here as part of the intro to the demo is 2 environments. Now, these environments have both been set up using ARM templates. They could have been set up using Juju, from what Nicholas suggested earlier, but to get this going, I've used ARM templates. Now, what we've got in the Chef Automate is our Chef server, which is our server that contains all our cookbooks and recipes for maintaining configuration management. We've got our compliance server, which holds all our policies that are going to check against our nodes. And we have our Automate server, which gives us our visibility and dashboard of what's happening to our nodes in that environment. That has been built by an ARM template that it's in GitHub, and links I can give you later. And then the Docker Swarm environment here has been generated, again, off an ARM template using the Azure Container Services Engine, which is a product you can download, or a script you can download from Microsoft's GitHub, and it can run on Linux and Windows, and it will generate your container system with whatever orchestrator you want. I then modified it so that our Chef extension, which installs the Chef client on each machine, was installed on each of those machines and all the agents, and the agents are deployed in a scale set so that you can wax and wane them depending on your needs. All machines in these both environments are running Ubuntu. So, quick pray to the demo gods to make sure this is working. And I've got a demo for you, and hopefully we are logged in. Yeah, okay. So, So this is Chef Automate, and in here you can see we have 4 nodes running in this environment. And if I go to these nodes, you can see that they're checking in every so often. Now, normally Chef client will check into the Chef server, see if any cookbooks are to be run every half an hour. But for demo purposes, I've made it so that the nodes are checking in every 3 minutes. Okay. Now, what I've got the run lists doing on here, and run lists are just the list of recipes that you want to run on that node for your configuration. What I've got it doing is running a compliance test for the Docker engine. Now, this is using a CIS benchmark, which is the profile is out on GitHub, and I'll show you how this gets pulled down. Now, at the moment, this node, which is the Swarm master, has 25 critical issues, and they range from the content trust, don't enable swarm mode, your certificates, and all the control files that Docker needs. Now, what you can do here is that these policies are open, and you can say, right, yeah, I'm really happy with that, but I'm not too worried about the trust for the content, so I can tell it to skip that policy. I'm not going to show you that now, but you can skip certain things. So what we're going to do now is fix a couple of these things using Chef Chef to remediate them, and we're going to check that the where is it? There's the permissions for the set the daemon JSON file ownership is set to root, and that the daemon JSON file are set to 644 or more restrictive. So to do that, I have my cookbook here, and in true demo style, it is all commented so that I can uncomment it and you don't have to watch me type. Although I can't use the keyboard anyway. And yep. Is that better? Okay. Oops, too much now. So we're setting this, and we're now setting that we've got the file we want to create using template, where that source of that file is from within the template of the cookbook, and what mode and the owners we want. So we now need to upload this to the Chef server. So I can use the integrated terminal of VS Code, and if we go into cookbooks, DevOps, what I need to do, because this is an update, and ideally your flow would be, I need to make sure that I've updated my version control, my version of my cookbook, and you would check that into source control, and it would go through a CI/CD pipeline, and then it would go through there. But for so we have to update to make it pick up the new changes, and we're using self-signed certificates on here, which is why I've got no. Oops. Oh, wrong one. Wrong command. I need it on the next one. So we have to tell that to update. That goes through and it checks all the dependencies for the cookbook. Ka-dunk, ka-dunk. And we've seen that we've got our new version of the DevOps cookbook 012. So then we do an upload. No, and this is where, now one of the things we do have to do is we need to make sure that recipe is being run on that box. Now the recipe is controlled by this base role. And so what we need to do is just say, okay, fine. What we do is we add that in. And we upload the recipe, the role, sorry. And we upload that. Now, what will happen is because our servers are checked to run every 3 minutes, then hopefully we're going to find that the nodes are due to run fairly soon. So we've got this one here, this one ran 2 minutes ago. So in about a minute, it's going to run the policy. Now, while that's waiting to run, you might be asking, well, why is this useful as me as a developer? Well, the inspect tooling can be run at any stage. You can run it on your workstation while you're developing to make sure you're managing your policies, that you're running your policies. The policies can be pulled down from your central compliance server or from GitHub, and they can also be part of your CI/CD pipeline so that you're checking at every stage if you're compliant with your policies. One thing I'm not showing here is how you would check your compliance for your containers. Now, this is because we're testing the infrastructure. And if Chef Client was running on each node, it wouldn't know what container, it would find a container, but wouldn't know what rules to run against that container because there's nothing linking that to. So what you would do is you would put that in part of your pipeline, and then you would say, okay, fine, thank you. I will check my build of my container. That will go into your registry, and then you know that's already compliant, and then you just run it. So that's that. So I'm very conscious of time here. This one has run, and what we should find is that you saw we had 24 problems or 25 problems. If I go into compliance now, we have 36, so it's made it worse. Okay. Not quite what I was hoping, and it might be to do with the way that I set the file up or whatever, but you can see it made a change in the wrong direction, so I apologize for that. But the idea is that you can build up your recipes and you can remediate these things and have them as a central system in your cookbook control. So in that, oops, come on, PowerShell. Not PowerShell, PowerPoint. So in summary, all the Docker Swarm agents are managed in Chef. You can repeatedly scan the servers for compliance. They run on the compliance runs every time Chef client runs, and you can report on non-compliance, which means that you could maybe report into Docker Swarm for some self-healing or whatever needs to happen there. There's some links for you there. I can publish them later. I'll be on the Microsoft stand today if you have any questions at all. Thank you.
So we've got... Is this on? Yeah, thank you. So we've got 1 minute left. We were hoping for Q&A, but I think what we'll probably do, actually, is ask people to just come down to the Microsoft stand. All of the guys will be down there to be able to answer any of your questions. This was a kind of like a punt for us, really, in terms of would we be able to fit this many demos into this amount of time. I think it went relatively well. And bearing in mind that we were running on a 4G connection as well, because the Wi-Fi wasn't that great, I think we did all right. So thank you very much, everyone, for coming along. And please do come down. We've got loads of swag on the Microsoft stand as well. T-shirts, squeezy penguins, the pens if you want one as well. So come down, have a chat to us, grill us if you want to as well. And we look forward to talking to you later. Thank you very much.